Hello and welcome back to our series of video tutorials demonstrating how to use RIOT SCADA. Today we'll be discussing how to add alarms and edit existing ones. First, we'll need to navigate to the admin panel and click on the Locations tab. You'll then need to navigate to the site that you would like to configure alarms for and open the Alarms tab. We have three different types of alarm that we can create: basic, custom, and pattern. For basic alarms, you'll need to be creative, come up with a name, and then refer to your Modbus map to fill in the address field. Basic alarms work with coils and discrete inputs. You can also assign it a category. This can help with organization, but it is not mandatory. After creating the alarm, make sure you click the cloud button to send the configuration. This will deploy the alarm and allow it to trigger. Custom alarms can be configured to trigger under a certain condition. Now, similar to a basic alarm, you can be creative and give it a name. Check your Modbus map to fill in the function code and address fields. However, if the data point already exists in RIOT and you just want to create an alarm that's referencing that data point, you can just click the Select Data Point option here and choose from the list. Regardless of which way you decide to fill in these fields here, the operator and value to alarm at fields are the same regardless. These are going to allow you to decide when you'd like the alarm to trigger. For example, if you want an alarm to trigger when a tank level dips below, say, 25, we'll want to set the operator field to less than, and the value to alarm at to 25. You'll notice the category field is here, just like it was with the basic alarms, and the same rules apply. It can be helpful, but it is not mandatory to fill in that part before you hit submit. Once you finish configuring your alarm, make sure you click the cloud button to send the configuration. This will deploy the alarm and allow it to trigger. Finally, we have pattern alarms. Pattern alarms could be described as anomaly detection alarms. We'll be giving the alarm a data point to monitor. The alarm will then look at a given date range. It will then run an average of the values that are found in that date range, and the alarm will then trigger if the data point is too far outside of that average. Pattern alarms are most helpful for tracking any potential issues with things like pipe pressure or motor temperatures, where the occasional spike or drop isn't a major concern, but consistent spikes or drops would indicate an issue. To configure a pattern alarm, we'll need to give it a name, as usual. This time, however, we'll need to point this alarm to a data point that is already saved in RIOT SCADA. We'll just stick with the lacked oil temp in this case. We'll next need to choose the date range that we'd like to work with. This controls how much historic data is taken into account for the alarm to fire. Updating this will also generate a chart that you can reference to have an idea for when the alarm will trigger. Next is tolerance. We have this set to 0 by default, since consecutive high or low readings is typically concerning. However, setting the tolerance to 1 will make the alarm fire when there are 3 consecutive high or low readings. Setting the tolerance to 2 will make the alarm fire when there are 4 consecutive high or low readings, and so on. Variance is what allows you to control what counts as a high reading and what counts as a low reading. I'll leave this at 30 for now. By default, the variance field will just look at the raw numbers pulled from the address tied to the data point, and then generate all of its charts using that information. However, if we'd like, we can change this to a percentage-based system. Doing so will allow it to read this number as a percentage of out of bounds instead of it just looking at raw numbers. And in the same way, we can change this, and we can now clearly see the upper and lower bounds in the chart. In many cases, the best solution here is just to kind of play around with the numbers here and try and get these bounds to be somewhat close to all of the peaks and valleys without actually cutting any of them off. And then if anything is performing out of band, that will make the alarm trigger. We can choose a constraint for this alarm as well. Maybe you want the alarm to track pressure, but only when a pump is running. In that case, you'll open up the constraint menu and choose the data point that indicates if your pump is active. Keep in mind, your constraint can only be a data point tied to a coil or discrete input. And if that data point that is constraining this alarm is inactive, then the chart that you're referencing will go away. So I'm going to put this back to none for now. Finally, we can disable the upper and lower bounds. If you're not concerned about any spikes in readings, then disable the upper bounds. If you're fine with any big drops in readings, then disable the lower bounds. Disabling both, as you can see, there's a little warning here that tells you, hey, this alarm won't work if you have both these boxes checked. So make sure you leave at least one of these unchecked if you want this alarm to function. As with all other alarms, once you submit your new alarm, make sure you click that cloud button to send the configuration. This will deploy the alarm and allow it to fire whenever its conditions are met. Before we wrap up, if you have any existing alarms that you'd like to edit, all you need to do is click the name of the alarm and then click the yellow edit button. That concludes our guide on alarm management. Thank you for joining me. Next, we'll be discussing how you can import data points into RIOT through an Excel spreadsheet. I'll see you there.